Hello, hello. All right, let's get started. I should just clean this up real quick. Hello, everyone. Welcome. We are about to begin the API workshop. And so this is going to be very interesting because this is kind of like the first unveiling of the API. And the API is very interesting because it's the world's first multi-agent API ever. And so we've been working very hard on the API. We've been trying to make it as fast and as good as possible. And this is kind of like our first ever workshop or live stream about the API. So I'm very, very excited about this. And yeah, it's going to be super fun showing you how it works and why we made this. So yeah, welcome everyone. Welcome. First, we can start off with what is the API, or like what is the purpose of the API. So the Swarms API is a highly optimized hosted version of the Swarms framework, delivering enterprise-grade performance and reliability. It basically takes all of our like the best features from our flagship product, which is the Swarms Python framework, including advanced multi-agent architectures, sophisticated multi-agent memory systems, agent-to-agent communication protocols, and much more. And the Swarms API is built with a Rust-optimized backend. It ensures unparalleled performance, and it also incorporates enterprise-grade security and compliance features like SOC 2 and HIPAA. And if you'd like to learn more, you could go check out the docs at docs.swarms.ai. And the docs are also new, which is pretty nice. So if you go here,
Hey.
you can see, you could check it out. Yeah, docs.swarms.ai. It's our new docs platform just for the API. So, and you could also test out here. We have like all the different endpoints that we'll be talking about pretty soon. And yeah. So yeah, that's kind of like a little bit more about the Swarms API. Now, some super cool key features that are basically provide the API. Its usefulness are a couple of things. So the API provides a vast array of capabilities, enabling enterprises to create production-grade agentic native applications. There's three main features. The first one is the agents endpoint. So this is one agent that allows you to build custom agents with tools, memory systems, MCP servers, and more. So within the agents endpoint, you can customize it. You can use any tools. You can use structured outputs. You can integrate MCP servers and etc. The second main feature, which is a little bit slightly more complex than agents, which are reasoning agents. So reasoning agents leverage specialized reasoning agents for super intelligence. So you can imagine this is kind of like, I wouldn't necessarily say this is multi-agents, but some of the structures are multi-agents. So self-consistency, for example, was a very highly popular reasoning framework. There was also a reasoning dual, which basically uses like a model like DeepSeek R1 and etc. And Tree of Thoughts is also another example, a reasoning framework that we worked on many years ago. And so yeah, that's kind of like reasoning agents. That's extremely new, but that's useful for tasks that require analytical reasoning, deep reasoning, and things like that. And the third and most important feature of the API is multi-agent orchestration. So this is what essentially allows you to orchestrate multiple different agents, and you could do so with sequential workflow, concurrent workflow, and hierarchical workflow. And you could choose over 12 or 13, 14 different multi-agent structures. We have a lot of them in the API that are natively supported. The three most used are sequential, concurrent, and hierarchical. And so I'll be demonstrating how to use this in code shortly. So additional features that make the API very fun and very reliable are multi-agent execution runtime. So the runtime behind the API is extremely optimized, and we've spent an inconsiderable amount of time trying to improve it and make it reliable. It also includes enterprise-grade security and has persistent memory systems for each agent. As I mentioned before, it supports diverse multi-agent architectures such as sequential, hierarchical, collaborative, voting, democratic conversations, round robin, and etc. You could also manage your agents and automatically generate your agents as well. It also includes logging and monitoring. It includes over 500 plus models from OpenAI, Anthropic, Cohere, Grok, and a vast array of other model providers. And it also has service tiers. So there's different types of tiers. Standard is for immediate execution, and Flex is for cost optimized processing across single swarms, batch operations, and even scheduled jobs. And so, yeah, that's kind of like a overview of the functionality and the features that the API includes. And now we'll be showing you how to get started and use the API. So first step to getting started is to make an account at swarms.world. And this is our platform, which also includes our marketplace. So if you go here, you'll see our marketplace. We have a vast array of pre-built agents. These agents can be from any model provider or any agent framework or anything. So this is just like our marketplace here. And if you go here, if you don't see all these apps, you could actually choose what type of apps you want to see. So in the apps gallery, you can select developer, and you only have the developer pages. And so now you'll need to generate your key. So you'll generate your key here. I already have a couple keys, so no need to worry. And yeah, so you just make your key here, and then we can move on. Yeah, so once you have your key, then the next step after that is to download the SDK. So we'll download the SDK briefly. You'll do pip3 install dash capital U swarms clients, and then you'll have the SDK. You could also, if you use UV, you could also use UV as well. So you do UV pip3 install dash capital U swarms client, because I know a lot of people out there like UV. So yeah. So yeah, that's how you install it basically. Then to initialize it, you import your clients. So you do import OS. This is to fetch your key. This is where you initialize the client. So you import this, and then you also import this. This is the env to get your key. So here you'll say client equals swarms client, and then your API underscore key equals dot get env, and then your key. Then you put your key in a .env file called swarms API key as listed here. And then that way it's initialized, and now you can start building your agents. So yeah, that's essentially how to get started. Now, once this is done, now you're at liberty to start building your agents. And so this is the agents endpoint or feature that we discussed earlier. And so now I'll show you how to do this in code, and I'll build a couple agents myself. Yeah, so with the agent endpoint, as I mentioned before, it essentially enables you to build custom agents that can leverage over 600 models, MCP servers, structured outputs, and a lot more. And so this is what it looks like. You give it a name, you give it a description. So here is an expert doctor specializing in interpreting and diagnosing blood work results. Then you have system prompts, and this is a system prompt here. And then this is where you would put like all your instructions and everything. And here you would put your model name. So the model name here would be, it could be GPT-5, it could be Claude Sonnet 4, it could be 4.1, and etc. And then you could also put the loops. So the loops is how many times the agents talk to each other. Well, talk to itself, I mean. So within the loops, if you set the loops higher to 10, then the agent will basically talk to itself for 10 times in a loop. And so that's very useful for chain of thought, tasks that require chain of thought. There's also a max tokens parameter, which is how many tokens the agent will generate. We actually just published a pretty good blog on how to extend this. If you want to build agents for creative writing or any form of task that requires the agents to generate a lot of code or content. And so the main task here is the way that the agent is executed is a task parameter. So the task parameter will basically be the main entry point into the agent. So this is an agent that analyzes blood work, and it says a patient presents with the following blood work results: hemoglobin 10.2, and et cetera, et cetera. This is an agent that analyzes blood work, and this is the task that the agent is going to be doing when you run it. So now, if we go to Cursor, we can get started on this agent. Yeah, so this is the example that I just mentioned. Going to clear this. And yeah, this is how it looks like. This is the code. As I mentioned before, we import this from Swarms, import Swarms client. Then we initialize the client. And we put the key. We could also put the base URL. So it's already set the URL, but if you want to change the URL for any reason, you can totally do so. And yeah, it also has a couple of more features, like you can set a timeout, max retries, and etc. Now for the agent, this is the example that we ran before. We can keep adding more and more settings here, configurations. The agent's structure has a couple of more settings that I'm not showing in this example. So if you go to the reference here, you can see all the parameters that the agent can take. Yeah, so you can give it temperature, you can give it a role, you can give it a tool, tools list dictionary, which is kind of like for structured outputs. So if you give it this, it'll output JSON. You can give it MCP URL. You can have it stream. You can give any additional LLM arguments, which could be like top P or frequency penalty and things of that nature. And you could also give a history and like a history of the previous conversation. You could also give it images. You can give it one image or multiple images and streaming. So yeah, it's has a lot of functionality, and it's pretty simple to use. So now if I run this agent, I could just run that, press that, and we'll see the output. So it's running. This is using Claude Sonnet, which takes some time. If you wanted this to be fast, then we could use a model from Grok. And so you could use models from Grok just by changing the name to Grok / whatever model you want. And so this is a response. It's going to output just a dictionary, but we can make it look better by using the JSON package. And I'll also show you an example of using the Grok GPT OSS model. So we can find the model for that. Say Grok console. So we just need to get the name. Then we're going to make this look simpler to view. And then we're going to try this. Yeah. Okay, so there was an issue with the model. If you ever have trouble finding the name of the model, something you could do is you can actually fetch all the models that we support by doing available. So I'll do that, and then we could find the model that we want. And so it returns a list of models that we can use. These are all models that we can simply integrate. So OpenRouter, Claude, any of the Claude series, any of the GPT-4 series, OReasoning series, Gemini, and Grok. So these are some of the Grok models. We can choose all of these, any of these. They have Llama, they have Mixtral, they have Kimi K2, which is pretty popular now. We could try that one. I'm gonna comment that, and then we're gonna go back here and put the model name. And there you go. That was the completion. And this is what it says: interpretation of abnormal findings, hemoglobin, it's analyzing some blood, CV not provided. This combined one anemia may hint at bone marrow stress or chronic disease, which is correct. Which is more typical of alcoholic liver injury, extrahepatic muscle injury, or congestive hepatopathy. Integrated pathophysical physiological considerations: Armenia plus leukocytosis, mild transaminitis, suggests a systemic process: infection, inflation, neoplasm, chronic disease that is both driving marrow neural response and suppressing erythropoiesis. I can't say that. But yeah, this is a medical example, blood work example. And this is how you would use the API in that context. So yeah, that's how you basically run single agents with the Swarms API. And then you can modularize them and make them composable. So yeah, that's about it. And then something interesting that we have another functionality called the batch agents endpoint. And so this feature is interesting because you could run multiple agents at the same time with different configurations. So they could be completely different agents, and there's also a 50% discount. So
right, and just this, right, and he just has, right, he's a very Catholic person.
What? Hello? All right. All right. So for the batch example, this is how it looks like. It's basically the same thing as we just shown, but it has multiple, like it has a list of entries. And so we can make them different just by saying make them. And now we could run any number of agents through a batch context with completely different agent configuration. So these are all different. This could be, you can have any form of agents here, and they could all be custom and specialized for different things. So yeah, you basically give a list, And it's a dictionary, a list of dictionaries. These are all different agents. And yeah, same parameters and same configurations as last time. Name, description, prompts, model name, loops, max tokens, temperature, and etc. Then we can run this. And give us the results. Again, to visualize these response, I would most typically recommend using JSON to better visualize them, because this is a raw dictionary, which is hard to understand. So we're just going to run it again. Yeah. And there we are. These are the results for the different agents. So we get a batch ID, total requests, and then we get the requests for each. These are all our responses from both agents. The second agent now is called the radiology report summarizer. So we gave it some task about X-ray analysis, and it says heart appears slightly larger than normal, mild cardiomegaly. Your lungs look clear and healthy. No signs of infection or inflammation in the lungs. No fluid buildup around the lungs or heart. What this means: the chest X-ray shows a mildly enlarged heart, but your lungs appear normal with no signs of pneumonia, fluid collection, or other lung problems. And yeah, that's how you would use the batch endpoint. Again, the batch endpoint is mostly for situations where you need to run different agents all at the same time. They're running different tasks. They're not going to be running the same tasks. So they're going to be running different tasks. So to have multiple agents running the same task, we're going to use another structure called the concurrent workflow, which we'll be demonstrating shortly. And yeah, that's about it for the batch agents endpoint. Now we have my favorite endpoint personally, which is the multi-agents endpoints. And so this is the endpoint where you could build multi-agent systems and you can run them all at the same time. So this multi-agent endpoint provides you with a vast selection of multi-agent architectures, such as sequential workflow, concurrent workflow, majority voting, and many, many others. So yeah, it has a vast array of features, such as you can specialize, you can provide a specialized list of agents. You can customize the agents as you wish. The agents are executed concurrently in Rust. And we also provide and fulfill all the multi-agent communication and memory. And yeah, let's get into it. And this is the code. We give it a name, description, swarm type, task, and agents. To see the list of swarm types that are currently available, then you can use this endpoint here available in the SDK, which is clients.swarms.check available. So if we run that, we'll see the different types of multi-agent structures that we can use. So we have agent rearrange, which is very interesting because the arrange allows you to define how the agents will communicate with each other. So you could build your own custom communication flows. The mixture of agents is described in the mixture of agents paper. Really, really good multi-agent architecture for research and things of that nature. Sequential is basically like agents will communicate sequentially. And we have diagrams for this for these multi-agent architectures in our main docs page. Yeah. So this is how the concurrent one works. You have a task, and then you give it to multiple agents, and then all those tasks are executed at the same time, and they're going to have different outputs, each and all of them. So this is one task to many agents. The sequential is looks like this. So you have a task. This task goes to agent 1, which goes to agent 2, which goes to agent 3, and it's kind of a more sequential process. Then there's round robin, and the complexity of the architectures will start to scale from here. We also have a group chat that emulates how group chats work. And we have a couple of other ones as well. But back to the demo, we can choose all of these just by copying their name and putting them in the swarm type. So here, I'm going to change this one to a sequential workflow. Oh, this is the task. Yeah, so now we have the swarm type, and now we have 3 agents that will run. So the list of agents that will run first, ICD analyzer will go first. This one will go second, and then this one will go third. And this example is also in healthcare, and it's about analyzing a patient who has a sharp chest pain that worsens with deep breathing, shortness of breath, and mild fever, dry cough, and fatigue. And these agents are basically going to analyze and try to discover the root disease or the root cause of this health issues. And so, yeah, that's basically how the configuration works. You can keep adding more agents, or you could add more parameters, such as in the case of agent rearrange. If you use the agent rearrange, you will have to put a new parameter called the rearrange flow. And so this one, basically, I'll show you now how it works. So for this, you have to make sure that the agents have dashes in their names, because you're going to be using their names here. So you could do something like this. So yeah, so this flow now basically says this agent's ICD-10 analyzer is going to talk to the ICD code explanation agents. And then it's going to talk to this agent as well. And so we could change this by saying, make sure these agents are unique. So now we have primary and we have secondary. And we could also change this. So this is sequential, right? This agent is going to talk to this one, and then this one is going to talk to this one. But we can make this concurrent. So if we say the ICD-10 analyzer is going to this, and we put a comma sign here, now these 2 agents will be activated in parallel. And so the rearrange flow is extremely customizable and extremely novel, as you can define the communication between these agents. But we're not going to be showcasing this example now. We're just going to showcase the sequential workflow, which is quite simple. And yeah, so now once we run this, we will see the results. So once this is complete, I'll stop sharing my screen, and then I'll see if there's any questions and or any inclinations. And so these are the results. Let's see. So this agent here, it rationalizes the ICD-10 analysis. So it provides the ICD-10 codes, sharp chest pain worsened by deep breathing, which is RO 7.2, which is correct. Precordial pain, RO 7.89. Other chest pain, platosis of breath, used when this is a prominent symptom, can be listed as a secondary symptom code. And so we can format the results again by using JSON dumps. And now it will run. Depending on how many agents you have in the swarm and what architecture you use, it may or may not. It may take longer time, or it may take shorter time. For example, the concurrent workflow is one of the fastest swarm types because they're all running in parallel. Whereas the sequential is one of the most time-consuming because all the agents have to first finish their query and then move on to the second agents and third and onward. And so this is what the results format looks like. So below is a concise clothes that match. And this is using GPT-OSS, which is very interesting and quite fast from Grok as well. And also very cheap, very fast and cheap from Grok. And then this agent is also providing its analysis as well. R50.9 when the fever is present, but the underlying cause, infection, inflammation is not yet identified. And then it goes deeper into its analysis. So yeah, this is the response formats. You have ID, status, swarm name, description, type, and then you have detailed billing information as well. So you have number of agents, service tier standard, execution time, then you have the number of input tokens, number of output tokens, and you can see a vast array of other parameters as well. And yeah. All right, so briefly going to stop streaming so we can see if there's any questions. And yeah. Oh, seems to be an issue. I was not sharing my screen. That's very strange. Unable to share screen. Huh. That is very strange. Okay, now. Okay. Can everyone see? That was so strange. I'm pretty sure I was sharing. That was so weird. Okay, so I'll just.
I could see you screen the whole time.
What was that?
I could see your screen the whole time.
Yeah, because we're on Discord, but I was also streaming on Twitter, and it doesn't seem.
FFF.
Pardon me for the issues there. Yeah, so I'll just briefly go like share everything that I missed again, very quickly. So let's start off with simple agent. So this is what a simple agent looks like. We import this, Swarm's clients, import the clients. We run the agent, so we give it a configuration. We have name, description, prompt. This is the prompt. This is the model name. And you can add more and more parameters as you wish here. Then you have the main task. And so this is one agent, just like one individual agent. And you could also check the models that are available here as well. So you can, if you run this, you see all the models that we support. So we have a lot of models. We have Grok, OpenAI, Snowflake, Azure, Databricks, Azure, Gemini, Perplexity, Stability, Llama, Anthropic. Yeah, there's over 600 models. So yeah, you could choose any of them. We also have OpenRouter as well, which probably opens up another 1,000 models or something, give or take a couple thousand. But yeah, that's what the kind of like individual agent API looks like. It's very simple. We've tried to make it as minimal as humanly possible. And then the batch endpoint looks like this. So it's literally, it's the same thing as this, except you can put in multiple different agents all in the same list of dictionaries. So this is a list. And then we have dictionaries, which are dictionaries of other agents. So we can give it more and more agents here, but they're all going to be running different tasks. So these are basically like you're running multiple agents in parallel, but they're all doing different things. They're not going to be doing the same thing. If you want them to work on the same task, you would have to use the concurrent workflow that I'll be showing you now. And so this is the multi-agent example. So here we have 3 agents. And this is what it looks like to run it. So it's, you have a name, description, type, and then you have the task. This is the main entry point for the swarm. We have the list of agents here. So we have 1, 2, 3. And yeah, so here we can change the name. So we just change the name to concurrent workflow. And we don't need this because we're not using agent rearrange. So yeah, now that this is operational, now we can run this. So now it's going to run. And yeah, I'll show you a couple of other architectures as well. You see how fast that was? It's extremely fast. If it's running in concurrent is probably the fastest multi-agent architecture there is, because other ones involve having agents having to communicate with each other. So they can take substantially more time than just this one. So this is the list of outputs. So we have 3 different agent outputs: ICD and analyzer, ICD code explainer secondary, and these are all conducting their analysis on this task, which is basically seeing what disease this woman has. So she has chest pain, shortness of breath. For 2 days, she has sharp chest pain that worsens with deep breathing, shortness of breath, especially when laying down, mild fever, dry cough, and fatigue. And yeah, that's essentially how this is what it looks like to use the API. It's relatively simple, but it's still very expansive and very high performance at the same time. So yeah, for the people that couldn't see earlier, again, excuse me for the issue. I'll just showcase how to get started again. So to get started, you just make an account at swarms.world. You get your key. So you go to /platform/API-keys and you make an API key, and then you download the SDK. This is how you download the SDK. You do pip3 install -U swarms, or you could do uv pip3 install -U swarms client. And yeah, that's how you would use the, that's how you would download the SDK. Now, for the initialization, to initialize the client is pretty simple. You just, from swarms_client, import swarms client, and then you just give it your API key here. Once the API is connected, then you can start, running your agents. So yeah, this is what we briefly discussed earlier, and this is the agent's endpoints, 600 models, MCP servers, structured outputs, and a vast array of other functionality is included as well. We also have the batch agents endpoints, where you can run multiple unique agents at the same time with different specializations, and there's a 50% discount. So that's very fun. And then this is the multi-agent endpoint that I just showed you. And yeah, I just want to show you a couple of more architectures here. So another very popular architecture is the hierarchical. So I want to show you that example now. We're going to build a new file, and then we're going to specialize this to let's create a small medical unit simulating real life units. Doctor, nurses. It will be led by the doctor. And so we're going to make a quick new example here with cursor. And then I'll show you how to leverage the hierarchical swarm. All right, let's try this really quick. I think it's working. Yeah, it's taking quite some time. Yep, this is the hierarchical. Okay, so it works. Now I'm going to change the model names for simplicity. We can also delete some of these max tokens, but I think it's okay. All right, so we're going to run the hierarchical swarm and we'll show you how it works. Now, the hierarchical swarm is should be used in cases where you will essentially need more autonomy and fully autonomous decision making and task distribution. So this would be useful when, for example, you wanted to create a fully autonomous medical unit where there is a team leader of some kind, or, for example, if you wanted to build a fully autonomous marketing department where there was a creative director, marketing director, or things of that nature, where you would need or have some form of hierarchy for these agents to communicate and distribute tasks to each other. And so these are the results. Here we can see the director calling multiple agents. So the director called nurse. Here I will see take the patient, vital signs, temperature, pulse, respiratory rate, blood pressure, oxygen saturation, and pain score. And so the director is distributing tasks now. Nurse Alice, thank you. I'll proceed with a focused respiratory assessment as follows. Focused respiratory assessment. Observations. Inspect for signs of respiratory distress, use of accessory muscles, nasal flaring, cyanosis, tripod positioning. Observe rates, depth, rhythm of respirations. Auscultation. Listen to lung fields bilaterally for breath sounds. Clear, dismissed waves, weaves, crackles, or rockany. And then the agents continue to work with each other. So the hierarchical is actually one of my favorite because it enables like semi-fully autonomous. It enables semi full autonomy, so you could have like fully autonomous teams always working together. So this is a quite popular swarm type, and it's used a lot for activities that require fully autonomous teams, or a team that is running a hospital operation, or a team, a hedge fund, for example, where there is some kind of lead partner or director of a fund. And yes, it could be repurposed for various different applications, but yeah. All right, let me check some questions. All right. Just making sure. Pip install swarms. Yes. Yeah, Adam, where's your coding screen? Thanks for letting me know. Quite late, but yeah. Let's say the AI cowboy. Hey, good work, Kai. The goat. Thank you, brother. Appreciate that. You're on the verge of something great. Thank you, John. Appreciate you, bro. All right. Let's showcase some other features as well that I would like everyone to know of. So here we have somewhere here. Okay, here are this is a list of various different. Oh. So there are some issues with sharing my screen. I wonder what it is. Unable to share a screen. What is this? Okay, now it took so long. We're gonna have to see what's wrong with these people. Yeah, so here we have a couple of different helper methods that are very useful to know. So you can check how many models are available using model list. So if I run this again, I ran this earlier. I don't think people might have seen this, but yeah, you can see basically like all the models that are available, and you would just change the model name parameter to accompany these changes. And so you would just go here, close it, and then health check. This is to just check to see if the server is running. It is running. You could also fetch your log. So every single the API is stateful, which means that if you wanted to get all the completions that you've ever done, you could totally do this. So if you run this, then you can get all your completions. I'm not going to run this now because I'll share some of the agents that I've been using. But yeah, I mean, you could totally do this on your side as well. So this is rate limits. You could see your rate limits by calling this endpoint client.client.rate.getLimits. So I have a premium account, so I have premium limits. If you want premium limits, then you can learn more at this. If you go to docs.swarms.ai, you could see this rate limits tab, and then you could see the rate limits for free tier and the premium tier. The premium tier on average gives around 5 to 10 and even sometimes 20x increases in rate limits. So if you're interested and you think you're going to use the API quite a bit, then we would recommend to upgrade to premium tier, which is approximately $99 a month. And yeah, you can learn more about the rate limits here and also the pricing here as well. And so this is the rate limits parameter. You could check to see also how many requests you've done today, or in the past hour, or in the past day even. So, and you can also see your maximum requests per minute, per day, and tokens per agent as well. So very, very helpful to have an endpoint just for this. And the final endpoint as well is to see what swarms are currently available for you. So for now, in the foreseeable future, all swarm architectures will be mostly free. So for free users that are paying per usage, that is that you don't have a subscription, then all these multi-agent architectures will be complimentary. But in the future, there will be simulations or large-scale multi-agent structures that premium members will only receive. And those will be for the new multi-agent architectures that provide some level of advanced reasoning that we have not seen before. So if you're interested in getting access to, entirely new and super intelligent multi-agent architectures, then in the future, then we would recommend you to join the premium plan as well. But if you don't want to do that, that's okay because it's free for now. And you only pay as you use the API itself. So yeah, these are some methods or utilities that are very useful, and you can use to find rate limits, to find the models that you support, and etc. And it's very simple to use, only a couple lines of code. And so if we return to our little presentation here, just a couple days ago, we announced a massive performance improvement. We really haven't done a full live stream or workshop on the API as of yet. And that's because we've been trying to optimize it and make it much more high performance. And so a couple of days ago, we shipped the latest update. And just to overview some of the updates, the new update provides 3 to 5 times faster JSON serialization. We also improved the number of concurrent requests that the API can support by 2 to 3 times, which is very important. We also reduced the API response times by 40 to 60% due to a combination of concurrent functionality and also compression through gzip. And we also integrated a UV loop for 2 to 4 times faster asynchronous operations. And if you want to learn more about the full change log, or you're just simply interested, or if you're interested in joining our team as an infrastructure engineer, in which we are hiring for, then I recommend you check out this change log here that shows all the different optimizations that we made to the API. And also, in the docs page, there are quick links to get your keys, management, and also technical supports. If you ever have problems with anything, if you ever have any issues or any bugs, or you just simply want to have questions, you could always book a call with the team and or me, and we'll be glad to assist you on your journey of building production grade agentic native applications. So yeah, we're always available for you. And yeah, that's about it. Thank you for joining the workshop. That's about it. Excuse us for the issues earlier about not sharing the screen. I think it was my fault, but it also seems Restream is having some issues with sharing their screen. So I will have to check that out. But I definitely remember sharing my screen, which is very weird. But I think there might be some issues or something. Yeah, so thank you for coming. I hope you enjoyed it. If you'd like to support us, you can support us by checking out the docs. Go to the GitHub. This is the GitHub for the SDK. Just look up swarms-SDK, and you can find the clients that I've been using this whole time, right here. And there's also the helper methods as well. I'll be posting these links probably below or in the Discord. So yeah, if you want to get the links, then you can. And I'm also going to post this PDF or presentation on YouTube and also Twitter, so that everyone can have this presentation and these links. Yeah, so if you want to get started building with the API, go to docs.swarms.ai. If you want to check out the GitHub, go to swarms-SDK. If you want to go to our website, go to swarms.ai. If you want to join our Discord, then click this link. We have now, I think, over 14,000 agent engineers and members of our Discord, so you should join. And then we also have our marketplace where if you build agents, you could share them on the marketplace as well and even monetize them. So yeah, lots of cool things to do in the Swarms community. So yeah, thank you everyone for joining. Let me see if there's any questions before we go. Also, by the way, everyone, this recording, if you're just joining now, this recording will be available on YouTube. So if you want to watch it again, then you can go on YouTube and watch the whole thing. So yeah. All right. Well, I think that's it for now. I'm going to be posting the links below in the Twitter and also on YouTube and on Discord as well. All right, everyone. Thanks for coming once again, and going to close this out now. Yeah, if you'd like to have a discussion with me, you could join the Discord. I'm in the Discord basically all day, and we also have technical support there. So if you have any issues, just let us know in the Discord. All right. Thank you, everyone. Thanks for coming. Bye-bye.